Hi guys, welcome to our video lecture series of Laplace transforms. So in our previous classes we have started inverse transforms and we solved some problems using some properties of inverse transforms, and in continuation today we will learn a new property of Laplace transform, that is the inverse transform of a function when s is multiplied by f of s, that is equals to the derivative of function of t. That function of t is given by this function of s plus function at 0 multiplied by delta t. So now we will use this property for solving some questions, and we will take some questions as a helping material, so we will learn how to solve the inverse transforms using this property. So let's take an example. The question is given, let's say that we have to find the inverse transform of s over s squared plus 1. So if I want to take the inverse transform directly like we took in our previous lessons, I can say that in the denominator it is s squared plus 1 and in the numerator it is s, so it is as much like as the inverse transform of s divided by s squared plus a squared. So from the inverse transform table we can see that this is cos a t. So now we can take its transform directly, but in this lesson we want to learn that how to solve the problem when s is multiplied by f of s. So I will break this problem into parts, that is s dot 1 over s squared plus 1, to make the problem as like as this property. So now our problem is like s dot f of s. So now I will use the property. First of all, I will find f of t using this f of s. Using this f of s, I will find f of t. So f of s in this case is just 1 over s squared plus 1. So if I want to find the function of t from this function, so I can take the inverse transform of this function, that will be equals to sine of t. From the table of Laplace inverse we can easily suggest that the inverse transform of this function is sine t. So now we have the inverse function, so apply the rule, that is derivative of the function sine of t, derivative of sine of t plus function at 0, that is sine of 0 multiplied by delta t. So the derivative of sine t is cos of t plus sine 0 is 0, so that is equals to cos t. So the Laplace inverse of s divided by s squared plus 1 is equals to cos of t. That's the answer. So now we will take another example and we will see that how can we solve that example. Let's say that we have to find the inverse transform of s over 4s squared minus 25. So I can break this problem again like we did in the previous section. 4s squared minus 25. Now this problem is like s dot f of s. So f of s in this case, f of s in this case is 1 over 4s squared minus 25. So I can simplify it further. I will take 4 the common, so I will left with 25 over 4 in the bracket, and again simplifying the function, so I can write it as 5 over 2 squared. Now I can see that in the denominator is s squared minus 5 over 2 squared. So from the Laplace inverse transform table we know that 1 over s squared minus a squared multiplied by a, that is equals to sine of hyperbolic at. So now in this case a is 5 over 2, but in the numerator 5 over 2 is missing, so I will multiply and divide 5 over 2 by the whole function, so it will be s squared minus 5 over 2 squared multiplied by, this is multiplied by 5 over 2, so I will multiply here by 2 or 5 to balance the equation. So what I get is 2 over 20 dot 5 over 2 divided by s squared minus 5 over 2 squared. Now I can take the inverse transform of this function easily by applying a is equals to 5 over 2. So the Laplace inverse, it will be 1 over 10, and the Laplace inverse of 5 over 2 divided by s squared minus 5 over 2 squared is equals to 1 over 10 sine hyperbolic 5 over 2t. So now we have got f of s. So now what is the next step to do is apply the rule, that is derivative of the function sine hyperbolic 5 over 2t multiplied by 1 over 10. 1 over 10 I can write it outside because it is constant, and plus the function at 0. So it will be sine hyperbolic 0 multiplied by delta t. So the answer will be this derivative of sine hyperbolic t is cos of hyperbolic t multiplied by the derivative of the angle plus 0. So it will be 5, that is 20 dot multiplied by 5 cos of hyperbolic 5 over 2t, that is equals to 1 over 4 cos of hyperbolic 5 over 2t. So this is the final answer. So the Laplace inverse transform of s over 4s squared minus 25 is just equals to 1 over 4 cos of hyperbolic 5 over 2t. So that was the problem. So we can take another problems and we can solve it easily using this property, and we will use this property in future for solving some differential equations and some inverse transforms, and we will learn some other properties also.